Here's a fun experiment that shows off the magic of gravity and fluid pressure. There's evidence that the siphon has been around since 600 BC, where the Greeks used it to punish you for putting too much alcohol in your cup. But what does the siphon even do? How is it even possible that water travels uphill with no forces added? I have here a glass full of water. Grab a straw and dip it into some water. Bubbles will start to appear, meaning the straw is having an identity crisis and is now full of water instead of air. With the straw now filled with the colored water, flip it over into the third glass like a pro. I took colored water so it's easier to see. Watch in amazement as the water starts to flow into the new glass, as if the straw has become a water wizard. The magic show ends when all three glasses have the same level of water, because gravity and fluid pressure have decided to call it a draw, as the pressure is equalized. As we know, the pressure depends on the depth and of course on the acceleration due to gravity, and also the density of the fluid. But those don't really change much over these small distances. In this system, it's depth that matters, not the volume of water. Now, let's see how you can have a straw that's full of liquid. How do you get siphon in action? There are a couple of ways to do that. We have already used one method to initialize the siphon by immersing both ends of the straw inside the fluid. Another way is to suck on the straw. However, if we want to siphon a liquid that we don't want in our mouths, we can easily pump out the air from the tube using a syringe or a dropper to suck out air from the rubber tube. We have already discussed the function of a dropper in another video. You can check out the link in the description box. We have used here a straw or a tube. Well, this is not just a tube. Basically, a siphon is a tube or a pipe that allows liquid to flow from higher level to a lower level without pumping or external force or any machine. What's the reason behind the magic? Here is a container filled with water at a higher level than another empty vessel at lower level. When I place this water-filled tube in the glass, water flows out and it keeps flowing. You can see that the water won't run forever. Eventually the flow will stop, and that will happen when the water level in the glass at the same height as the exit point of the straw. The flow will get weaker and weaker, and finally it will stop and the system will be in equilibrium. At this point, the forces acting on the fluid cancel each other out and the fluid stops moving. What are the forces? For a siphon, most relevant force is weight due to gravity. Every single molecule of air and water in this system is being squeezed by the weight. Let's see how it works. In the diagram, what we have been looking at, a glass filled with water and a straw that is also filled with water. The exit of the straw is at the same height as the liquid in the glass, placed at the left side, and nothing is flowing. Let's take a look at the pressure. Let at the left side of the straw, the depth of the straw just below the water be h1, the height of the straw from the surface of water be h2, and the depth of water level at the exit end of the straw be h3. As the pressure is directly proportional to depth that's coming from the water in the glass, causing water to go into the straw. And we also have a column of water of h1 inside the straw that's creating a pressure in the opposite direction. So they both cancel each other out. At the left side, the pressure exerted by the air column on the water level and the upward pressure of air exerted on the straw at the right end are the same. So the air pressure also cancels out. Similarly, at the left, the water level h2 is the same as the depth of water at the right, which is h3. That means we have the same pressure out of the straw into the glass at the left side as we do out of the straw into the right side. So nothing will move. However, if we bend the straw so that the depth of the outgoing part is increased, which means h2 is greater than h3, there will be greater pressure outside the straw than inside it. As a result, the water will flow out until the water level in the container has dropped to the same level as the exit, restoring equilibrium. This happens because the liquid is pulled down by gravity and the pressure difference between the two ends of the tube.
We are still missing a fundamental force that's essential for the siphon, called the cohesive force. This essentially means how well molecules in the liquid stick to one another. This force comes into play at the top of the siphon when the water is divided into either side.
Let's have a look. If I add more water to any glass, the water level in that glass will rise, creating a greater pressure relative to other two glasses. Consequently, the water will flow into the other glass. This process will continue until the water level in all three glasses is equal in height. Once again, we can utilize the same pressure difference phenomenon in real life situations. such as cleaning fish tanks by removing debris and excess water without disturbing the fish, transferring fuel from one container to another, and more.
Thanks for tuning in. See you soon. And in the meantime, keep experimenting at home.